Hello, so today's video is just going to be a brief video about transformations of trigonometric functions and specifically translations in the x direction and also stretches parallel to the x-axis. That's what we're going to really focus on today. So let's consider a sine graph and a cos graph like these two graphs here. So the sine graph there, the cos graph here. Now let's think about what would happen if we shift this sine graph to the left by pi over 2 radians. So you've got pi over 2 there, 3 pi over 2 there. So if we just pretend to shift this to the left by pi over 2, so this point becomes that point, this point goes to pi over 2 there, this point there goes to pi there, take away pi, and 2 pi goes to there. So what we get, let me just get rid of this dot so it doesn't confuse me. So when we shift this to the left, we now get this red graph here, which is the cos graph. So when we shift sine to left by pi over 2, well, that gives us cos, so that gives us cosine. Okay, so when we shift this to the left, so basically one of these like graph transformations, remember we did these graph transformations in previous videos. If you've not seen those videos, you can go to my graph transformations playlist and watch the videos on graph transformations and function transformations. So this is kind of like a transformation y equals f of x plus pi over 2. So when you add the value inside the function, you actually shift the graph to the left. So when we shift the sine graph to the left, we then get cosine. And how about if we consider the cosine graph? So what I'm going to do with this cosine graph is just draw a black line again going to there just to carry this graph on. Now, if we shift this to the right by pi over 2, what do we get? So this now goes to over there, this point. Let me get rid of the blue line again. Oh no, I didn't mean to do that. There we go. Then this point there moves to pi. This point down there moves to 3 pi over 2. And then this point moves to there. So now we would get, and of course this point, this dotted point there would move pi over 2 across to that. So now we get our sine wave. So we now got a sine again when we shift it to the right by pi over 2. So what that's telling us is that if we shift cosine to the right by pi over 2, we get sine. Okay, so this is kind of like a transformation y equals f of x minus pi over 2, because remember when we shift a graph to the right, we take away the constant that we're translating by in the x direction inside our function away. So let's look at a summary of this. So that means that sine x is the same as cos of x take away pi over 2. So when we shift the cos graph, this cos graph here to the right, we get sine. So when we do cos x of x take away pi over 2, so shift it to the right, we get sine. So sine x is equal to cos of x take away pi over 2, because y equals f of x take away pi over 2 is a translation by vector pi over 2, 0. So that's a translation to the right. So when you translate the cos graph to the right by pi over 2, you get sine. And a similar thing down here again. So when you when you translate the sine graph to the left, so this sine graph to the left by pi over 2, what you're really doing is you're doing sine of x plus pi over 2, so you're shifting to the left, and then you get cosine. So we know sine x is cos of x take away pi over 2, but cos is sine of x plus pi over 2, and that's because y equals f of x plus pi over 2 is a translation to the left by a vector of minus pi over 2 and 0, so translation to the left. So that's just I guess some facts on sine and cos transformations, well, specifically translations. Now let's look at some transformations parallel to the x-axis. So now we're going to apply, for example, y equals sine of 2x in the first example. Then we've got y equals a half of x in the, sorry, y equals cos of a half x in the next example, and then y equals tan 3x in the next example. So remember when we multiply the value of x inside the function, we're actually doing a scale factor. So a scale factor 1 over 2 parallel to x-axis. So we're squishing it in basically. So parallel to x-axis. So we're going to squish the sine graph in. So before the sine graph has a time period of 2 pi, so it finishes at 2 pi. goes halfway between at pi, and does the kind of wave shape that we've seen before. So it's kind of like a wave shape like that. But this time we're going to squish it in by a factor of 2. So what we're actually going to get this time is we're going to get a graph like this. So we're going to get the sine wave repeating itself twice within 2 pi. So that's what our graph's going to look like. And we've got pi over 2 there. We've got 3 pi over 2 there. So that's what our sine graph looks like. Now, how about cos? So if we go again between 0 and 2 pi. So we know originally the cos graph kind of looks something like this. This is our normal cos x graph. But when we do a cos of a half x graph, the scale factor is now 1 over a half. So that's a scale factor of 2 parallel to x-axis. So actually now we're stretching it outwards parallel to the x-axis. So really what we're doing now, if I just rub out all these dots. So really what's happening now is that we're gonna stretch it outwards. So now the graph is gonna kind of go like, maybe not like that, but more like this instead, and then continue onwards and onwards like that. So now we stretched it out. So now, so cos of pi, cos of half x when x is pi, that's going to give us 0. And then cos of a half x when x is 2 pi, well, that gives us cos pi, which is actually -1. So that's why we get -1 down there and 1 there. And of course, up there, that's 1, and that's -1 there. So tan 3x, so again, this is a scale factor parallel to the x-axis, but this time 1 over 3. So 1 over 3 parallel to x-axis. So in this case, your tan graph, which before was something like this, so it was something like this before, we were asymptotes there, then it was like that, asymptotes there, then it finished at 2 pi there. So this time we're going to squish it in basically 3 times. So this kind of shape's going to repeat itself 3 times. So we finish off at 2 pi. So this time we're going to go up to, if we do 2 pi divided by 3, then we get 2 pi over 3. So if we put our 2 pi there, 2 pi over 3 there, and then 2 pi over 3 plus 2 pi over 3 gives us 4 pi over 3. Sorry, let me draw my line back in again. So like that. I'll get rid of this line there. So then we've got 4 pi over 3 next. So this tan graph, remember, has asymptotes. Well, it did have asymptotes at pi over 2 and 3 pi over 2. So now we want to divide those by 3. So now we've got asymptotes at pi over 6. So pi over 6 there. And also, we're going to have an asymptote at 3 pi. Oh, well, so if we have one at 3 pi over 2 before, divide that by 3, we get 1 at 3 pi over 6. So basically a half pi. So we get 1 at half pi there. So pi over 2, an asymptote there, and our other asymptote at 2 pi over 6. Sorry, 2 pi over, or rather, other asymptote is going to be at pi over so originally, again, it was pi over 2. You want to divide by 3 to get pi over 6. We got 1 at pi over 6 there. So that's our next asymptote. Okay, so we got that. And then, so the graph is going to go like that. Then pi over 6 is going to go through the middle there. And then you've got your asymptote again at pi over 2 as your next asymptote. And then after that, again, the graph's going to repeat itself, go through 2 pi over 3 there, then go upwards to your next asymptote. This time the period of the graph is 2 pi over 3, so you want to add 2 pi over 3 to get your next asymptote of your graph. So pi over 6 plus 2 pi over 3 is the same as pi over 6 plus 4 pi over 6, which gives you 5 pi over 6. So that's your next asymptote of your graph. And then again, the graph repeats itself. And we just got to be careful to make sure we include all the correct points. So it goes like this. Again, an asymptote just before there, goes like that. Asymptote just before there, goes like this. Asymptote just before the 2 pi, just before 2 pi, and then like that. So that's what your graph would look like. So again, we've got the pi over 6 asymptote we've got the other asymptote, which again is going to be pi. Sorry, this is not pi over 2, is it? Sorry, my bad. Let me do this again. So the original one was at pi over 2. We want to divide that by sorry, not not pi over 2, 3 pi over 2, which is the one I'm thinking about. So 3 pi over 2. We want to divide that by basically our factor of 3. So yeah, that will certainly give you pi over 2. So yeah, we get 1 at pi over 2 again. So that's our pi over 2 asymptote there. Pi over 2. And then 5 pi over 2. Your next asymptote is going to be pi over 2 plus 2 pi over 3. So that's going to be so 3 pi over 6 plus a 4 pi over 6. So that's going to be 7 pi over 6 there as our next asymptote. And then the next one's going to be 5 pi over 6 plus 2 pi over 3. So 5 pi over 6 plus 4 pi over 3. Sorry, 4 pi over 6, which is 9 pi over 6. So basically 3 pi over 2 again. And then the last asymptote here is going to be 2 pi, 7 pi over 6 plus 2 pi over 3, so 7 pi over 6 plus 4 pi over 6. That's going to be 11 pi over 6 there. So that's we got there in the end. So that's eventually how we would determine the asymptotes with this graph here. You just want to squish your tan graph in by a factor of 3, so a stretch parallel to the x-axis by a scale factor of a third. And then this time you'll get 6 asymptotes, 1, 2, 3, 4, 5, 6 this time, compared to 2 before with the tan x graph. So that's just a brief summary of some graph transformations with these trigonometric functions.